Today we're going to talk about cloud and virtualization security. This is Module 11 or Chapter 11. This is part of our CompTIA Security Plus study in our textbook. And if you study all the material, you could go and potentially take the CompTIA Security Plus exam and get certified. Okay, so by the end of this module, you should be able to list and describe the different types of clouds and their location. No, these are not clouds out in the air, but cloud computing refers to things that use a network or on the internet. So you want to describe their locations, architectures, and models. Describe cloud security controls and explain virtualization security. So, as we get introduced to cloud computing, it's a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. That's a long definition, and you could just say, if you think of like Google Docs or Microsoft OneDrive, things like that, those are all cloud computing examples. These are entities that offer cloud computing that are called cloud service providers, like the ones I mentioned, plus others. Cloud computing cost savings is due to the following factors. You have the elasticity and scalability, you have the pay per use, on demand, and resiliency. A good example of this is like the Google Drive. If you ever go later on your own, just go and Google the words Google Data Center. There's some really good videos that are out there. One of them gives you a virtual or a tour through one of the Google Data Centers led by one of the directors. And it's really interesting because you get to see how Google, when you get onto Google Drive or your Google Docs, what goes on behind the scenes. So this is an example of a cloud computing. So you see all the computers here on the network going from the left to the right. You also have your wireless access point for those wireless devices like the laptop and the cell phone. And you go out to the internet and it goes on to the other side to the cloud provider, the router and their servers and so on and so forth. And really all you're doing is you're just remotely connecting. The word cloud computing, you're just doing it something that's outside of your computer. So you have what's called an on-demand service. They can make changes, increasing or decreasing computing resources without requiring any human interaction from the service provider. Like on Google Docs, you can get more storage, pay for it, get more storage, change, create folders, do all kinds of different things. There's universal client support. Virtually any network device, desktop, laptop, smartphone, tablet, can access cloud computing resources. All they have to do is connect and authenticate, and they're in. And there's invisible resource pooling. The physical and virtual computing resources are pooled together to serve multiple simultaneous consumers that are dynamically assigned or reassigned based on the consumer's needs. The customer has little or no control or knowledge of the physical location of the resources. And you have immediate elasticity. So again, you can increase the size of your drive or your storage or decrease it to meet whatever demand you might have. And the fees are based on the computing resources used. So it's a metered service. So you have different types of clouds: a public cloud, a community cloud, a private cloud, and a hybrid cloud. So the public cloud is one where the services and infrastructure are offered to all users with access provided remotely through the internet. So that's your Google Docs and things like that. A community cloud is a cloud that's open only to specific organizations that have common concerns. Say like the YSU cloud. Back then, years ago, they had the YSU Y Drive. Now it's gone to the Microsoft OneDrive. You have a private cloud, creating and maintained on private networks. Your company where you work at might have a network attached server or its own little cloud. Or a hybrid cloud is a combination of both public and private clouds. And here's your locations of the clouds. Here's a figure showing the computing locations. On the left, you have your computers, on-premise, enterprise LANs, wireless access points, connecting to the internet. So instead of using a centralized model, cloud computing takes place in several different locations, or a decentralized model. So again, here are the different types listed out, the description and examples. Edge, you see the edge, that's where your Internet of Things device might go. So your cloud architecture, you have things called a thin client. It's a computer that runs from resources stored on a central cloud server instead of a localized hard drive. In the past, you had your computer was a big bulky machine that was probably either a desktop or a tower, and you had hard drives, CD-ROM drives, you had other types of access and things like that. Now you don't need that. Your data is now stored on the cloud. All you need is a connection to the internet. So you can see now today's laptops, tablets, and things like that, they're thin. That's a thin client. You have your transit gateway. It's an Amazon Web Services technology that allows organizations to connect all existing virtual and private clouds, physical data centers, remote offices, remote gateways into a single managed source. Okay, so remember, a transit gateway is an Amazon Web Services technology, AWS. You can have a serviceless infrastructure where the capacity, planning, installation, setup, and management are all invisible to the user because they're handled by the cloud provider. If you've ever gone into like web hosting, like GoDaddy or some of the other ones, that's where when you buy your hosting, you're basically renting those computers out there in the cloud. So you have your cloud models. You have software as a service, platform as a service, infrastructure as a service, and anything as a service. And these are important as we address software as a service. That's where the vendor provides access to the vendor's software applications running on a cloud infrastructure. Platform as a service, the computers install and run their own specialized applications on the cloud computing network. And infrastructure as a service, the vendor allows the customers to deploy and run their own software, including operating systems and applications. Anything as a service is a broad category of subscription services related to cloud computing. And so here's an example of a three-tiered architecture. Tier 1 is your web servers. Tier 2 are the application servers. And Tier 3 are your database servers. So you might have these users A, B, and C that make a request on a web server. It goes through the switch to the application server, maybe running some program on the application server, and then the application server might need access to the database, and it goes to Tier 3, the database server. So if you go to like Amazon.com, you're getting into the front end, and then that program is attaching to the application, the online catalog program, and then that program is attached back to the database that lists all the items that are in your shopping cart. So with all the clouds out there, they can't run by themselves, so they need cloud management. So cloud management can be conducted by the local organization performing the work itself or by contracting with a third-party management service provider. So the services integration, they attempt to achieve a boundaryless approach. So all you really need to do is say, well, I need more, I need less, can you do this, can you do that? And they make the changes on the back end without you having to worry about anything. So you're integrating all the users across the enterprise who are using cloud computing. So when you manage the cloud computing locally, it's important to have written resource policies in place. And that's important. A managed service provider, or MSP, delivers services through ongoing and regular support as well as active administration of those resources. An MSP can manage the customer's premise in the MSP's own data center, in a third-party data center, or in cloud computing environment. A managed security provider can also assist with or fully assume cybersecurity defenses. Your cloud native microservices, those are traditional application designs often called monolithic because the entire program is developed as a single entity. The solution to a monolithic application design is to divide it into smaller entities. Each entity is a specialized part of the code known as a microservice. The microservice architecture has smaller and more specialized elements, each of which manages its own database, generates its own logs, and handles user authentication performed by the microservices or the APIs. Here's a picture example of monolithic versus microservices. On the left side you see one central entity, monolithic architecture. You have the user interface, the business logic, the data access. Whereas a microservice architecture, you have that user interface, but then it connects to a microservice, then to another microservice, and then to another microservice and another one. So you have several databases. So it's basically spread across multiple machines. Also, too, in a way that's good because on the left side with a monolithic, you have what's called a central point of failure. If that machine or that setup goes down, the entire thing goes offline. Whereas here it's spread out, so if it goes down, only that particular part would go offline. Okay, so let's take our knowledge check activity here. Number 1, Arsene has been given a project to manage the development of a new company app. He wants to use a cloud model to facilitate the development and deployment. Which cloud model should he likely use? Software as a service, XaaS, IaaS, and PaaS. Remember, he wants to use a cloud model to facilitate the development and deployment. Remember, don't peek ahead to the answer. You should be able to think this through, because when you're sitting down for the test, even like the CompTIA Security Plus test, you won't have necessarily any notes that you might be able to look or no way to look ahead. So you want to be able to think this question through and come up with a reasonable answer. Okay, so we should look at its PaaS. Platform as a Service provides the software platform on which the enterprise or users can build their own applications and then host them on the PaaS provider's infrastructure. The software platform can be used as a development framework to build and debug the app and then deploy it. So the answer to this question, if you want to use cloud model to facilitate this, he wants platform as a service. So let's look at cloud-based security. Virtual security devices can provide protection in cloud computing environments. A cloud firewall is a virtual software that functions in a similar manner to a physical security appliance by examining traffic into and out of the cloud. Okay, so you have your secure web gateway, examines both the incoming and outgoing traffic and performs basic URL and monitoring web applications. The Secure Web Gateway also analyzes received traffic, performs data loss prevention, and provides alerts to a monitoring device like SIEM appliance. A cloud access security broker is a set of software tools or services that reside between an enterprise's on-prem infrastructure and the cloud provider's infrastructure. A CASB acts as a gatekeeper, ensuring that the security policies of the enterprise extend to its data in the cloud. A Secure Access Service Edge, or SASE, is the convergence of several security services into a single cloud-delivered service model. Various technologies that make up SASE include SWG, CASB, Zero Trust Architecture, and WAN technologies. So here we have a list of them: unauthorized access to data, lack of visibility, insecure APIs, compliance regulations, and system vulnerabilities. So those are the cloud vulnerabilities, the first part of them. So you have improper cloud security configurations. Organizations can have limited or no visibility in the security mechanism. While APIs help customers customize their PaaS by providing data recognition, access, and effective encryption, threat actors can exploit a vulnerable API. And compliance regulations: maintaining compliance requires that an organization know where their data is, who can access it, and how it's protected. But this can be difficult in an opaque cloud system where the transparency is lacking. And the system vulnerabilities: that's where a cloud infrastructure is prone to system vulnerabilities due to complex networks and multiple third-party platforms. Okay. So here's another table. User responsibility varies, cloud responsibilities. We're spread this from on-premise, information as a service, platform as a service, and software as a service. And you can see with on-premise, pretty much everything is here. As you go information as a service, platform as a service, and finally software as a service, you have more of that who's responsible for this. So your physical networks use the Open Source Interconnection, or OSI, 7-layer model to illustrate network functionality. With cloud computing, the OSI model is no longer as useful. The lack of the conceptual model like the OSI model makes selecting and managing security virtual devices more challenging. So you have different cloud-based conceptual models are starting to be proposed. However, no single model has been widely adopted. That's an important thing to remember. On your cloud security controls, you have conducting audits. A cloud security audit is an independent examination of cloud service controls. Use regions and zones. Reliability and resiliency are achieved through duplicating processes across one or more geographical area, called a high availability across zones. And secrets management. It's enabling strong security and improved management of a microservices-based architecture, allowing the entire cloud infrastructure to remain flexible and scalable without sacrificing security. You also have the enforced function area mitigations. We'll see that in the next table here. Hybrid clouds have a special security challenge called hybrid cloud considerations due to their nature of spanning both public and private spaces. Okay. Our best practices of hybrid clouds include the following: encrypting sensitive data, data traffic between two clouds, and inspect all encrypted traffic. Monitor and audit configurations and use automation rather than a manual management. Run regular scans to identify weak points. Secure all endpoints. Enforce zero trust security. Remember, we talked about zero trust security. So here's our knowledge check activity number 2. Based on a common respondability matrix, which of the following is a cloud service provider not responsible for? So what is a cloud service provider not responsible for? The devices, physical hosts, physical data centers, physical network. None of the above. Well, it has to be one of these. Remember, 3 of them are true. One of them is going to be false. Which one is he not responsible for? Okay, and that's going to be the devices. Cloud providers are not responsible for the devices, but leave this duty to the users. That's important. And you can almost go back and look that each of them had, cloud, cloud, cloud. But the devices, the cloud service provider is not responsible for the devices. Okay, so virtualization is a means of managing and presenting computer resources without regard to physical layout or location. I don't know if you've ever been on like a virtual computer where you log in and you're running a remote session and you're working on the computer that way. Your host virtualization is a type of virtualization in which the entire operating system environment is simulated. So you're not running the actual operating system, you're running a simulation operating system. So a virtual machine is that simulated software-based emulation of a computer. The host system runs a VM monitor program and supports one or more guest systems. So virtualization is used to consolidate multiple physical servers into VMs that can run on a single physical computer. The virtual machine monitor program is called a hypervisor, which manages the virtual machine operating systems. Now, this is an important point. There are 2 types of hypervisors. Type 1 runs directly on the computer hardware instead of the underlying operating system. So when you boot it up, it's going to run that hypervisor. And then it's going to load the virtual machine. Type 2 runs on the host operating system, much like an application. So once you boot up your computer to Windows, Linux, Unix, or whatever, then you run the virtual machine monitor program, the type 2 hypervisor. And then you run a third program, which is your actual virtual machine. Okay, now you can think about that, and that becomes a little bit more like a burden for a computer, because the computer is having to run its regular operating system, and then it has to run the hypervisor, and then it has to run the virtual machine. So, yes, it can be done, but you don't have as much flexibility. If you're going to be running multiple virtual machines, then okay, maybe you want to be able to switch between 1 and 2 and 3 and 4. Whereas if you just want to run one, sometimes it's better to use a type 1 machine. So you're not tying up all of the resources. So here's an example of the type 1 and type 2. So you see here we have on the left side you have the hardware. You're booting up right into the hypervisor. That's the operating system that loads the hypervisor. Then you have the ability to run guest operating system 1, guest operating system 2, and run their respective packages. Application 1, application 2. Okay, and then you see the type 2, you have the hardware, you have the host operating system on that computer, then you load the type 2 hypervisor, and now you can run guest operating system 1, guest operating system 2. The functionality can be the same. It's no different really, it's just how the resources are being used. So then you have what's called a container that holds only the necessary operating system components that are needed for a specific application to run. So it reduces the necessary hard drive storage space and RAM needed. It allows for containers to start more quickly because the operating system does not have to be started. A common application of virtualization is a virtual desktop infrastructure, or VDI, which is a process of running a user's desktop inside a remote virtual machine, or VM, that resides on a server. So this is what a container would look like. You have the hardware, you have the host operating system, you have the container engine, you have then additional binaries or libraries, and then the application that would run. So you can see here we have binaries group 1, binaries group, and libraries here for number 2, and it's running 2 applications in that container. There are advantages of virtualization. New virtual server machines can be made available, host availability, and resources can be easily expanded or contracted as needed. Host elasticity. With virtualization, it can reduce costs. Fewer physical computers must be purchased and maintained. It can also provide uninterrupted server access to users. So like if there's only, normally if there was like 10 computers and we had 30 people, well, it would be difficult for everybody to use the computer all at once. Whereas with a virtual machine, and everybody can access that. Your virtualization supports live migration, which allows virtual machines to be moved to a different physical computer with no impact to the users. So all we're really doing is transitioning that virtual desktop, so to speak. And then here's another term, infrastructure as a code. The software-defined network virtualizes parts of the physical network so it can be more quickly and easily reconfigured. This is accomplished by separating the control plane from the data plane. If you remember in your network, like on the routers, you had independent routers or you have managed routers. Okay. If the traffic needs to flow through the network, it receives permission from the software-defined network controller, which verifies the communication is permitted by the network policy of the enterprise. Once approved, the software-defined network controller computes a route for the flow to take place and then adds an entry for that flow in each of the switches along the path. So here's an example of a software-defined network. There's your data plane, the router, the packet switches, other network devices. Their protocols are being controlled by the control plane. Routing, traffic control, and so forth. Then through that API to the actual software-defined network applications. And then on top of all that is your business applications. A software-defined wide area network, otherwise known as SD-WAN, is a virtualized service that connects and extends enterprise WAN networks over large geographic distances. Your SD-WAN is designed to solve challenges associated with a traditional WAN, such as integrating connectivity between the service provider and the organization. A software-defined visibility is a framework that allows users to create programs in which critical security functions can be automated. The SDV allows network administrators to automate multiple functions in a network infrastructure, including dynamic response to detected threat patterns, adjustments to traffic mode configurations for inline security tools, additional IT operations management functions and capabilities. So how do you do the security? Well, there's security concerns for virtual environments. Security-related advantages of virtualization include testing the latest security updates by downloading it on a virtual machine before installing it on production computers. A snapshot of a particular state of a virtual machine can then be saved for later use. Testing the existing security configuration or security control testing can be performed using simulated network environment. Your VMs can promote security segregation and isolation. Security-related advantages of virtualization include a suspicious program that can be loaded onto an isolated virtual machine and executed, like sandboxing. If the program is malware, only the virtual machine will be impacted. Security concerns for virtualized environments also include not all hypervisors have the necessary security controls to keep out attackers. Existing security tools were designed for single physical servers. Virtual machines must be protected from both outside the networks and other VMs on the same physical computer. A virtual machine may be able to, quote, break out from the contained environment and directly interact with the host operating system called VM escape. It's also important to have a virtual machine escape protection. What that means is a user or attacker in one VM can break out of that virtual machine, go to the operating system level, and even jump into another virtual machine. Virtual machine sprawl is a widespread proliferation of VMs without the proper oversight or management. Combating VM sprawl is called virtual machine sprawl avoidance. Installing a virtual machine manager can help with this. Another practice is to use tools to harden the hosts. One tool is Security Enhanced Linux, or SE Linux. And here's a picture of the virtual machine manager. You can see the different virtual machines and how they're configured. Then all the active virtualizations alerts on the right hand side. These pictures are also in your textbook too. Okay, here's our knowledge check activity number 3. Which type of hypervisor runs directly on a computer's hardware? Hint, there's only 2 of them, and the answer to this question is one of them. There is no type 3 and there's no type 4, so the answer is going to be either A or B. Remember, one boots right into it, which is your one type, and the other boots into it on top of the operating system. That's your second type. So if you're not sure, you want to make this so that or understand this so that you can grasp it right away. Your answer is going to be a type 1 hypervisor. Type 1 hypervisor runs directly on a computer's hardware instead of the underlying operating system. Type 1 hypervisors are sometimes called native or bare metal hypervisors for that purpose, because they just run right on there and don't require an operating system. Okay, I think we've reached the end of the chapter here. So you want to rate your competence on the following module objectives on a scale of 1 to 5, where 5 indicates you have full confidence on your competence of that objective, and 1 indicates that you have very little confidence on your competence of that objective. If you score less than 4, you should consider reviewing the module and the related exercises. You want to list and describe the different types of clouds and their locations, architectures, and models. So you also be able to describe the cloud security controls and explain virtualization security. Okay, so here's our summary. Okay, that's it on this chapter. See you in the next chapter. Have a nice day.